In this video, we're going to take a closer look at covalent bonding and how or what sigma and pi bonds are and how they relate to this bonding. So let's start and remind ourselves that a covalent bond is an overlap between two atomic orbitals. We saw that in the hybridization video. If you're not quite sure what I mean, make sure you go back and re-watch that video. So when we have overlap between atomic orbitals, there are actually two possible ways that atomic orbitals can overlap. They can overlap end to end, and this is called a sigma bond, or given the symbol sigma. The other one is side to side overlapped, and this is called a pi bond. So let's take a look at each of these a little bit more closely and see what they look like. So a sigma bond, as I said, is end-to-end overlap. And so, for example, if you had, say, a hydrogen, H2 molecule, then these two 1s orbitals are overlapping end-to-end in order to form a covalent bond. You could have the same with hybrid orbitals. So if, for example, we had sp3 hybrid orbitals, and overlap them end to end, we would form a sigma bond between those two hybrid orbitals. Now, pi bonds, on the other hand, are side-to-side overlap. Typically, these happen with unhybridized p orbitals. Okay, not always the case, but quite often in the examples we'll see in this video are all unhybridized p orbitals. And so p orbitals, if you remember the shape, have these two lobes. And so they can overlap side to side. And essentially they are overlapping then in two places to form one pi bond. So we would have two sort of regions of electron density where we're having these two p orbitals overlap. And this creates a single or one pi bond. So what do you need to know then for sigma and pi bonds? Well, you can look at the makeup of either a single, double, or triple bond, and you can break it down into how many sigma and pi bonds there are. Every kind of bond has at least one sigma bond. So a single bond, a double bond, and a triple bond all have one sigma bond. Double bonds also contain one pi bond, and triple bonds contain two pi bonds. So let's look at examples then and see sort of what this looks like and how we can explain and determine all the different sigma and pi bonds. We'll start with a molecule called ethane. So ethane has two carbons joined together and then three hydrogens joined to each of the two carbons. If we take a look at just one of the carbons, it has four bonding pairs and no non-bonding pairs. So the carbons form sp3 hybrid orbitals. Now, we can have then end-to-end overlap of those orbitals. So between two sp3 hybrid orbitals, between the two carbons, that's going to create a sigma bond. And then between the carbon and the hydrogen, we have overlap of an sp3 hybrid orbital with a 1s orbital from hydrogen. And that is also forming sigma bonds in each of these. Okay, so because we have all single bonds in this molecule, there are all sigma bonds in this molecule. All right, let's move on. Look at another example then. So in this one, we have C2H2, which is ethene. And so ethene has a double bond between the carbons and four hydrogens. Two of each are joined to each of the carbons. If we take a look at one of the carbons, it is got three things bonded to it, no non-bonding pairs. So this is based off of a trigonal planar shape. And we know that for trigonal planar shapes, we have sp2 hybrid orbitals. So what's happening here then is the carbon to carbon, We have sp2 hybrid orbitals that are overlapping end to end, so that's going to form a sigma bond. Between the carbon and the hydrogen, similar to ethane, they're going to form sigma bonds. And then the double bond, or what's left over, if we've got sp2 hybrid orbitals, is that there's one p orbital left over with each carbon. And so those p's stick up and down like this on each carbon, and you get side to side overlap in both of these regions, forming a pi bond. So this molecule, the double bond, is made up of one sigma and one pi bond. All of the other single bonds are made up of sigma bonds. Our last molecule then is ethine, so that's C2H2. That's a carbon triple bonded to another carbon. Each carbon then is attached to one hydrogen. If we look at just one of the carbons, it's got two bonding pairs, no non-bonding pairs. So this is based off of a linear electron domain. And so we have sp hybrid orbitals, and we would have two p orbitals left over for each carbon. So the sigma bonds in here between the two carbons are overlap of two sp hybrid orbitals. And then the p orbitals left over are here, and maybe we'll do another color here. Okay? And so you get that side to side overlap between the p's left over. So the purple ones overlap, and then the blue ones overlap. So you have, in the triple bond, you have one sigma bond from the end-to-end overlap of the hybrid orbitals. And then you have two pi bonds because you have two side-to-side overlapping happening between two separate p orbitals. Okay, and then between the carbon and the hydrogen, again, that's end-to-end overlap, so that is a sigma bond. So we would say the triple bond has one sigma, two pi bonds, and then the CH is just a sigma, and that other CH is just a sigma as well. Okay, so that's three great examples of sigma and pi bonds, what they look like, how this overlap happens. That's it for this video. We'll see you in the next one.